As I invite you all to the session of the differential equation. In this session, we are discussing about a differential equation. Before going to discuss about a differential equation, I like to introduce about a derivatives. What is actually a derivatives? Everybody know about a derivative as a dy by dx. Actually, for defining dy by dx, we have a function y is equal to f of x. Here in this function we have x is one of the variable and as well as y is also another variable. Y stands with the help of x, that is why y is we treating as a dependent variable, and as well as here x, this stands without the help of the any variable, and this is what is called independent variable. This is what is called independent variable. We are differentiating this function y with respect to the help of the independent variable x. That already everybody knows it, and before discussing the differential equation, we have to understand about this dy by dx, and sometimes instead of this dy by dx, we are treating another notation with another notation, that is y dash. So, y dash is also treated as dy by dx. So, what is actually differential equation? The differential equation is an equation which involves derivative. Differential equation is an equation which involves the derivative, which involves the derivative. So, we can have some examples of a differential equation. Before that, I like to categorize our differential equation into two, and first one is the ordinary differential equation. And the second one is the partial differential equation. And we focus our discussion on ordinary differential equation. Simply we call it as a ODE. And ODE means, as we discussed earlier, this is also a differential equation. This is a differential equation which involves the ordinary derivative. Ordinary derivative. What is the ordinary derivative? The ordinary derivative is nothing, that is the dy by dx. It is the first order ordinary derivative, and d square y by dx square is the second order ordinary derivative, and d cube y by dx cube is the third order derivative, etc. We can have up to the nth order derivative. Generally we call it as d raised to n y divided by dx raised to n as the nth order derivative. So, any of the differential equation which involves any of these derivatives, that is what is called the ordinary differential equation. For the convenience, we are describing that as a generally as a function for the first order ODE. Just I can represent this as a f of x y dash equal to 0. That means this is a expression, it's a mathematical expression, and which involves x, y and y dash. No other higher derivatives involves in it. For the second order differential equation, we can represent as f of x y dash y double dash equal to 0. That means This is a mathematical expression which involves x, y y dash and y double dash. And in general, the nth order ODE can be represented as f of x, y, y dash, y double dash, etc. the nth order derivative. We have to involve the nth order derivative yn equal to 0. Here this y dash stands for dy by dx, and here we have y double dash, this stands for d square y by dx square. This stands for d square y by dx square. And yn dash, that is yn, this is equal to d raised to n. Actually this is the nth derivative of the dx raised to n, nth derivative of the function y. And this is the generally we are representing differential equation. We can move to some examples of this differential equation. See, here we have some examples. This is a differential equation, dy by dx plus x equal to e raised to x. It is an equation. An equation is nothing, that is a mathematical expression which contains an equal to sign. That is why this is an equation, as well as which involves the derivative, and therefore this is a differential equation. This is differential equation and it contains the dy by dx. This dy by dx stands for what? Y dash. Therefore we can express it involves y dash as well as x and as well as the function in x. So this is coming under the category x, y, y dash equal to 0. Therefore this differential equation is a first order, am I right? Is a first order, and as well as which contain first order, which contains the ordinary derivative. Here we are discussing only about the ordinary derivative, and therefore first order ordinary derivative. Therefore this is a first order ODE. And as well as we can comes to another example, that is comes to example 2. The example 2 I am representing as d square y by dx square plus p of x, any function in x, in and into dy by dx plus y equal to 2 raised to x. In this equation there is a derivative is there and dy by dx is there, y is there, d square y by dx square is there, some functions are x is involving. That is why we can write this as a, how can we write this? We can write this as an expression x involves, some x involves as well as some function in x involves, and we can write y involves as well as dy by dx involves, dy by dx stands for y dash, and as well as d square y by dx, that is y double dash, is also involves. That is why we can write this as, this is comes under the category of f of x, y, y dash, y double dash equal to 0. So this is a second order, and the derivatives are ordinary derivative. That is why this is a second order ODE. This is a second order ODE. Now we can move to the order and degree of ODE. Order and degree of ODE. Order and degree of ODE. Already we discussed the order of a differential equation. Among this differential equation, See, in this example, here also a derivative involves. The maximum order derivative is dy by dx. That is why we call it as a first order differential equation. As well as in this differential equation, see here the maximum order derivative is y double dash. That is why we call it as a second order differential equation. So, what about the order of differential equation? Order of the differential equation is the order of highest derivative. Order of the highest derivative. It is the order of the highest derivative. What about the degree of differential equation? Degree of differential equation is the degree of highest derivative. Degree of highest derivative. Degree of highest derivative. Degree of highest derivative. What is the degree of highest derivative? That means, see, for example, we can have a differential equation. Simply I write in terms of y double dash plus 2xy dash plus y equal to e raised to x. I like to make a change here. Instead of y dash, I like y dash square. I like to make a change instead of y dash as a y dash square. See, all powers. In y double dash the power is 1, in y dash the power is 2, and in y the power is 1. E raised to x is a function in x, and here in y dash you have a maximum power, but as according to the definition, the degree of differential equation is the degree of the highest derivative. So, which is highest derivative? This is y double dash is the highest derivative. Therefore, order of differential equation equal to 2, and as well as the maximum power of the highest derivative. Maximum power of the highest derivative. Which is the maximum power of the highest derivative? Only y double dash is only exists here. That is why its power is maximum power is 1. Therefore, the degree of differential equation is equal to 1. So, we can say that this is in this example, this is a differential equation, and as well as this is a ordinary differential equation. This is a, we are discussing always about ODE. This is a ordinary differential equation, and this is a ordinary differential equation of order 2 and degree 1. We can come to another example. Example 2 come. I write y double dash plus y triple dash whole square plus xy dash plus y equal to g of x, some function in x. Simply I write one more example. Listen, here what are the derivatives involved here? Y dash is there, first order derivative is there, y double dash is there, second order derivative is there, y triple dash is there, third order derivative is there, and in this third order derivative is the maximum order derivative, highest derivative. Therefore, order of this ODE, order of the ODE is equal to, order of the ODE is equal to 3. Order of the ODE is equal to 3. And what about the degree? Degree of the highest order derivative. That is, highest order derivative is y triple dash. So, order 3, the power of y triple dash, the maximum power of y triple dash. Here only the y triple dash only exists only one time, therefore its power, therefore the degree is equal to 2. Therefore, degree is equal to 2. We can move to some problems to find the order and degrees. Example 3, dy by dx plus e raised to x is equal to 0. And simply we can say that it involves only dy by dx. the first order derivative. That is why we can say that it is the order is equal to first order, and as well as its maximum power. Its maximum power, it contains only here only dy by dx is only here. That is why there is no power. That means the degree is nothing. Degree is equal to 1. And we can move to one more example, the example 4. In example 4, we can write as, I write this is 1 plus y dash square whole raised to 3 by 2 equal to y double dash, equal to y double dash. Clearly, with the inspection we can understand y double dash is the maximum derivative. Highest order derivative is y double dash. That is why we can understand the order of differential equation is equal to 2. And we have to find the degree of differential equation. The degree of differential equation is the maximum power of the highest derivative, that is degree of the highest derivative. That means we have the maximum degree of the y double dash, but here the power of y double dash is 1. But see, here the power is rational power. So, if there exists any of the rational power, have to change that is into integer power. So, taking square on both sides, squaring. So, after squaring, what will happen is that 1 plus y dash square whole raised to 3 by 2 whole square is equal to y double dash whole square. So, 1 plus y dash square whole raised to 3 by 2 whole square, that is 1 plus y dash square whole raised to 3 by 2 whole square, that is equal to whole cube. This is equal to y double dash whole square. That means all the powers are integer powers. Now, here we know that the highest order derivative is the y double dash, am I right? And because of this is the highest order derivative, maximum power of the highest order derivative is equal to 2. Therefore, degree of this differential equation is equal to maximum power of the highest order derivative, that is equal to 2. I like to move on one more example. Example 5. See a differential equation, that is 1 plus y dash plus y double dash whole raised to 3 by 5 is equal to y triple dash. See here on the right side, the maximum highest order derivative came here, and on the left side all the derivative are lesser orders, and on the left side have a rational power is there. We have to make all rational powers as the integer powers. So, what we need to do, take a powering both sides with 5. What will happen? Powering with 5, powering with 5, what will happen? This is 1 plus y dash plus y double dash whole raised to 3 by 5 whole raised to 5 equal to y triple dash whole raised to 5, y triple dash whole raised to 5. What will happen? This is equal to 5 comes to here. Therefore, the left side is changes to 1 plus y dash plus y double dash. Instead of 3 by 5, it will changes into whole cube, and in the right side y triple dash whole raised to 5. See what will happen here, it is the maximum power, maximum order derivative is the y triple dash. Therefore, we have order the order of differential equation, order of this ODE is equal to 3, and the maximum power of the power of the highest derivative, that is the power of the highest derivative is 3, the y triple dash, therefore its maximum power is 5, therefore degree of this differential equation is degree is equal to 5. See, compare these two examples. Here, as I said you earlier, here in the left side containing lesser order derivative and the right side containing only one derivative, which is the highest order. And on the left side the rational power is k. On the left side the rational power is k. Like that, here in the left side, see the left side and as well as the right side containing the highest power derivative, and the left side is the all the lesser order derivatives are there, and as well as its lesser order derivatives have a rational power. In that rational power the denominator is 5. So, see the order of this differential equation, that is the denominator of the rational power, and as well as here, see here in this rational power the denominator is 2, the right side is containing only one single highest order derivative, therefore this denominator is the degree of differential equation. So, we can have a we can have a simple conclusion from here. It is that if a differential equation containing, if an ordinary differential equation containing both derivative and its left side have a rational power, and all the in expression of the left side all the derivative are lesser order than the right side, and the right side containing only one derivative, then simply we can say that the denominator of the rational power is the degree of the differential equation. Okay, we can move to the next example, that is 1 plus y dash plus y double dash whole raised to 5/2 equal to y triple dash plus y dash. Listen, as we said earlier, this is the rational power 5/2. We will focus on the denominator of the rational power. So, we are squaring both sides because denominator is 2 squaring. So, we have 1 plus y dash plus y double dash whole raised to 5/2 whole square equal to y triple dash plus y dash whole square. So, we will have here in left side 1 plus y dash plus y double dash whole raised to 5/2 whole square equal to whole raised to 5. This is equal to a plus, as like a plus b whole square, we can expand y triple dash whole square, and next one is 2 into y triple dash into y dash plus y dash square. The differential equation is somewhat lengthy, but even though easily we can identify which is the highest order derivative. The highest order derivative is y triple dash. So, we have the order is equal to 3, but see the highest order derivative y triple dash exists 2 times. That is why we discussed earlier, it is that the highest power of the highest order derivative. The highest power of highest order derivative y triple dash is equal to 2. That is why we can say that the degree is equal to 2, the maximum power or highest power of the highest order derivative. See here, while expanding this you will get power 5 for y dash, power 5 for y double dash, but even though that is not a degree because the highest power of the highest order derivative is equal to 2. Now, we can move to one more example. We can move to one more example. See, the next example is 1 plus y double dash whole cube equal to 1 plus y dash 1 plus y dash. What about the degree of differential equation? The degree is, we can expand this as like a plus b whole cube 1 3 3 1. That is, instead of 1 it is 1 cube is there, 3 into 1 into plus 3 into 1 into y double dash plus 3 into 1 into y double dash square plus the last, instead of last one, 1 into y double dash the maximum power, that is cube. Here it is equal to 1 plus y dash. Like in last example, by seeing this differential equation we can understand y double dash is the highest order derivative. So, we can say that order of this differential equation is equal to 2. And similarly, there are 3 y double dash that exist, and these 3 y double dash, you can see here the power of y double dash is equal to 1, the power of y double dash is equal to 2, the power of y double dash is equal to 3. Therefore, the maximum power is 3, therefore, degree equal to 3. So, simply we can say that this is a differential equation which is second order third degree differential equation, second order third degree differential equation. In similar way, I am moving to one more example, is that 1 plus, same question, I am changing the powers, 1 plus y double dash whole raised to 3 by 2 equal to 1 plus y dash. As like before examples, here we have a rational power is here. Firstly, our aim to remove the rational power. So, the denominator of rational power is 2. That is why we are squaring both sides, squaring. So, 1 plus y dash y double dash whole raised to 3 by 2 whole square is equal to 1 plus y dash whole square. 1 plus y dash whole square. Therefore, this is equal to, we can write this as 1 plus y double dash whole cube is equal to 1 plus y dash whole square. Therefore, while expanding, as like in previous example, we can write this as 1 3 3 1. This is equal to 1 cube plus 3 into y double dash plus 3 into y double dash square plus, we can write this as a y double dash whole cube, y double dash whole cube equal to, we can expand here, it is 1 plus as like a plus b whole square, 1 plus 2 y dash square plus y dash, sorry, 2 y dash square. Clearly, we can identify that here it is y double dash is the highest order derivative. Among this highest order derivative, there are 3 powers are there, 1 2 3. The maximum power is 3. Therefore, we can say that this is the differential equation of order equal to 2 as well as degree equal to, as well as degree is equal to the maximum power of the highest order derivative, that is 3. Okay. Now, in our discussion, we discussed about the differential equation and the general format of a differential equation, as well as we discussed about a general degree and as well as order of the differential equation. See, in a differential equation, you know that the different order derivatives are there. from very preliminary classes we discussed it is that dy by dx, or it can be written as y dash. This is the first order derivative. D square y by dx square equal to, we can written as y double dash, and d cube y by dx cube equal to y triple dash, etc. In general, we discussed d raised to n y divided by dx raised to n is equal to the nth derivative of y. That is simply we are denoting it as yn. And any of the differential equation, this all derivative we call it as ordinary derivative. Ordinary derivative. And any of the differential equation involving this ordinary derivative is the ordinary differential equation. And we discussed it is here it is that order of differential equation as well as the degree of differential equation. The order of the differential equation is the highest order derivative involving the differential equation. Highest order derivative involves in the differential equation. And the degree of the differential equation is the degree of highest order derivative, is the degree of highest order derivative. Now, our aim is to solve the differential equation. On the next sessions, we like to discuss about the solution of the first order ordinary differential equation. Thank you for watching this one. Continue the watching. Thank you very much.